Hi, I'm Ken the Metal Professor, and I'm here to do a solution to a problem posted on the pre-calculus subreddit a couple of days ago. At this point, it's been long enough that we should be out of spoiler territory, and I'm just going to show how this thing plays out, because it's just an interesting sort of cross between a geometry problem and an algebra problem. And sometimes when I do these, I'll do 2 or 3 problems, but I spent a lot of time making the slides for this thing, as you'll see. So I'm just going to stick with this one. It comes from a user that sounds like he or she has an unfortunate condition. The dog is barking because the Amazon Prime truck has pulled up outside. So I'm just going to hang on for a second here. Okay, they've quieted down now. So this problem involves a line and 3 squares, and it's posed as, here are 3 squares on a figure, which you'll see in a second. Each one has a vertex sitting on a particular line, 3x plus 4y equals 24, and based on the positioning of the squares with the line, we have to decide on the dimensions of each square. This is what the picture looks like. So the line 3x plus 4y equals 24, you can check that the intercepts of 6 and 8 ought to be correct. And then big square in the middle, and then smaller squares to the right and to the upper left. And then you can see each one of those does have a vertex that sits on this line. And so we have to use this figure to decide what the dimensions of the squares are. The fact that I was able to do this picture means I got the right answers because I needed to know the coordinates of these vertices and the lengths of the sides of the squares to put them in the figure to begin with. So it's all going to work out fine. So here's the big secret. Since the shapes involved are squares, their length and width are going to be the same. In particular, if we call that length and width common value L, let's not stretch ourselves here, the upper right corner of that square is going to have coordinates L and L. And that corner sits on the line as prescribed. So here's that figure again. So the big square, we're going to say it has a width of L. It also has a height of L. And so since the left corner, the lower left corner is at the origin, the upper right vertex has coordinates LL. And that's where the line comes into play. The equation of anything, a line, a parabola, a circle, it doesn't matter what it is, the equation tells you what all the points on that thing have in common. And so points that sit on this line, if you take 3 times their x coordinate plus 4 times their y coordinate, you'd better get 24. And so this point, having coordinates LL, and that point sitting on the line, that means that 3 times the x coordinate of L plus 4 times the y coordinate of L has to be 24. And so without too much sweat and tears, we can solve for L. It is 24/7. And so now we know that this vertex on the big square is at the point 24/7, comma 24/7. Now, with that as a foothold, now we can go tackle either one of these squares, and I've chosen the lower right square to begin with. And we're basically going to play the same game. It's just that we have to work a little harder to write down the mystery coordinates of this vertex. So again, this is a square, so I'm going to label its common length and width as lowercase a. Since the big square already is known to have a length of 24/7, that means that the x coordinate of the vertex of this smaller square is 24/7 plus a. The y coordinate of that vertex is just going to be a, right? So this vertex here has coordinates that look like so, and that, coupled with the equation of the line, just like for the middle vertex, can tell us what A is. So this point with x coordinate 24/7 plus A and y coordinate A sits on the line 3x plus 4y equals 24. And let's do the same thing as before. 3 times the x coordinate of this point plus 4 times the y coordinate of that point must be 24. multiply it out, combine some terms, do a little simplification, divide by 7, and now we know that the width and height of this lower right square is 96/49. It's a hair under 2. I think it's like 1.96. And we can actually get the coordinates of that vertex. Remember the original 24/7 plus a hair more, and then that same little distance a up to the y coordinate there. So that was the story about the lower right vertex. And now let's take a trip up here to this upper left vertex. Same story one more time. We're going to label the width and height common value of this little square as b. The x coordinate of this vertex right here is just b itself, but the y coordinate, well, we have to start down here at the x-axis. We go up through the big square to a height of 24/7, and then go b more. And so that vertex right there has an x-coordinate of b and a y-coordinate of 24/7 plus b, and that vertex lies on this line just like the two other vertices. So we run through this one more time. 3 times the x-coordinate plus 4 times the y-coordinate equals 24. Multiply out, collect the constants, divide by 7, and we now know that the width / height of that upper left rectangle is 72/49. And so we even have the coordinates of that mystery vertex. And now I realize there's a typo. This is the upper left square, not the lower right square. I copied and pasted the old slide, and I forgot to update that text, and I'm not going to go fix it now. But this is a summary of everything that we've learned. Just starting with the fact that we had these 3 squares nestled under this line, and knowing that they are squares, that allowed us to find the dimensions of the big square first, and then use that as a foothold into this vertex, and also the dimensions of the lower right square and the upper left square. So now we know the coordinates of those vertices, we know the dimensions of those 2 squares, we have found all the things. And like I said at the start, I know that these values are correct because that's the information I used to generate this picture to begin with. I told the plotting software to put a vertex at this coordinate and this coordinate and this coordinate, and they all landed right where they were supposed to based on that line. So I have confidence that these numbers are correct.